Okay, so today's kind of a throwback to something in Algebra 2 that you probably spend a good amount of time on, but it's always rusty whenever you're in pre-cal and you start it again. It's very rusty. It's going to seem a lot easier the second time around, though, I promise. So what is the theme? The theme of the day is composition of functions. Okay, so that's your title for this section, composition of functions. And let's talk about what that means. Well, composition, just in the normal English language, right, it sort of has to do with composing. And you see the word functions is plural. So this pretty much means putting together two or more functions in a variety of ways. And that's it. So let's write that out. Putting, or how about we say working with two or more functions. And I'm going to make this kind of lengthy. In a variety of ways. To create something new. So whenever you studied this back in Algebra 2, what you see down here might look kind of familiar. I hope it does look familiar. I'm naming a function f, and then we're naming a function g. And let's just talk about what you do remember doing with this. Okay, you may remember a lot of what you're about to see. Hopefully, even if you don't remember much, you remember something like this, right? And we're not necessarily composing functions yet. We are just going to talk a little bit about function notation as a warm-up, right? This is just a quick review. So f of 3, you may remember that the 3 is in the spot of the x that's up here. So 3 is being placed into the function. So all that you have to do is go to the equation and replace the x with a 3. Okay, and so that is something you definitely should remember from Algebra 2. Now, what if it's not a number but a symbol, and that's supposed to be a dollar sign right there, okay? So g of dollar sign, well, that just means that instead of x being the independent variable, a dollar sign is the independent variable, and so you would literally just plug it into the function. So I guess I need a dollar sign squared minus $2 minus 8. Okay, now what does that mean? I don't know. It means nothing useful right now, but we're just practicing the substitution part, okay? All right, what about something like this? G of awesome. It's kind of the same thing as above. Don't get wigged out if it's like a word or a sentence or even a paragraph. Whatever is inside of the parentheses is what gets put into your function, and it will replace the variable that was there before. So this is going to be awesome squared minus 2 awesomes minus 8. Look at that. Now that just looks awesome. All right, so that's sort of how that works. And as a last little warm-up, let's do one more like this. I found that these scare people for some reason. Even though we've practiced substituting in, I have a lot of people that will just copy down f of x, and then they'll put a plus 6 at the back. Okay, that is so not right. All of this is in parentheses, so all of this gets plugged into your function wherever the x was. What was that? Okay. So what does that mean? It means that it's 2 times something plus 1, and the x comes out from up above, the x comes out, and the x plus 6 goes in. Now, for full credit, you do want to work this out. Don't be lazy. Go ahead and distribute 2x plus 13. All right, coolio. And that is stuff, all of this, guys, is stuff that you should remember from last year. Okay, so now what? Well, now let's step it up a notch, and let's combine functions with other kinds of math operations. All right, so I'll give you a minute to sort of write this down, but notice I'm using the same two functions as before, so you may not need to recopy anything. Just consider these 4 more examples that we are going to talk over, and hopefully you do still remember some of this from Algebra 2. What I'm going to do on each of these is write down sort of an expanded form for what this means, and then we're going to plug and chug, and that's pretty much how these always go. So just keep in mind, if it's f plus g and it's grouped of x, okay, the of x just means keep your variable in x, but now you're going to do f plus g. So another way that this could be written is f of x plus g of x. These are synonymous, guys, so think about it or write it whichever way you like. And now that you've done that, you just plug in the junk above. So f of x is 2x plus 1, and then plus, I'm going to recopy that plus, and then g of x. So g of x was blah, 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 blah. Now, you've got all that written out. Are we going to stop? No, we're not going to stop. We're going to combine like terms, okay? Clean it up. Make it look good. So it looks like an x squared. Ooh, those are going to cancel. And then minus 7. I think I did that right. Okay, so that would be your final answer for f plus g of x. So g minus f of x, you may have already jumped ahead of me and started it because you're awesome and you're bored. Good for you. So let's make sure you're doing that right, okay? The number one mistake people make is the minus sign because they actually do recognize that we are just subtracting the g function minus the f function, okay, so it is g of x minus f of x, but this negative, they forget it's going to really affect everything behind it. So you're going to see me starting with, okay, the g of x, so that's easy to recopy, g of x, okay, I'm going to write that minus sign, and then the f of x, I'm going to write that in parentheses. Now, why should I write that in parentheses? Well, you're grouping it together because it's not behind a plus sign anymore. It's behind a minus sign, and you need some sort of a reminder that I better be distributing that negative, or I better be subtracting both terms. So I definitely use parentheses just so I remember not to forget to distribute that negative, and then I put it all together. So this will be an x squared minus 4x and then minus 9. Does that look right? I think it does. Okay, cool. So that's kind of how that works, okay? All right, now what about the next one? We've got g f of x, okay? So what does that mean? Well, that just means g times f of x, okay? G times f. So we really are going to just be multiplying. So it's written, it's the same thing as this. We're just multiplying g times f. So x squared minus 2x minus 8 times 2x plus 1. So what do we do with this? Well, you guessed it, we get to multiply that madness, and that's not going to be fun. So I'm going to shut up and just sort of math it out right now. I'm a big fan of just distributing. I'll distribute this to all three, then I'll distribute that. So let me work it out, and why don't you work it out, and then let's see if we get the same thing, okay? Okay, that's what I'm getting. Feeling pretty good about it. I kind of double checked it as I was going. Noticed I had missed a couple of exponents and fixed that, and then I combined like terms. But anyways, that's what I'm getting. If I'm wrong, feel free to make fun of me as a class, okay? All right, the next one is f over g of x, and that really is just f divided by g. Now, these are the ones that you have to be careful on, and I'll show you why just immediately. I think it's going to jump out. Okay, f of x over g of x. Now, keep in mind, guys, anytime you have a fraction, we really have to think about the fact that the denominator cannot be equal to 0. Okay, and the reason that the denominator, in this case g of x, cannot be equal to 0 is because that would make this function undefined. So what that means is once you plug in the stuff, so let me plug in the f of x over the blah 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 blah. Okay, once you plug this in, You are done, you're pretty much done, but you do need to let somebody know out to the side if there's a restriction on the function, what that restriction is. So in other words, what is x not allowed to equal? Well, you got to figure that out. You got to ask yourself, okay, what number for x would make this denominator 0? And whatever those answers are, you've got to stick them on the back right here. So hopefully these things will factor, and I'm looking at this. Let me try to factor it real quick. It looks like it factors into, because you're just solving it. You're setting it equal to 0 and you're solving it. So let's see, 4 and 2 maybe, and maybe this one's a minus and this one's a plus. Awesome. Okay, that is how it factors. So x would be equal to 4 and negative 2. So that means your restriction is x cannot equal 4 and negative 2. Why not? Because if you plugged in a 4, you'd get a 0 on the bottom, which is bad. If you plugged in a negative 2, you'd get a 0 on the bottom, which is bad. So make a little note, maybe star this one to, don't forget the restriction. That is worth at least half the points. Half of it's slapping it together, half of it's the restriction. So be really careful with that. Okay, so can this get difficult? Because so far, I think this is pretty fair. It's not too difficult at all. This might be the thing from last year that gave you bad dreams. I don't know. We're going to actually now begin the composition of functions, meaning that we were composing them earlier. We were adding, subtracting, multiplying, and dividing. But now we are going to truly stick them together and create something brand new as well. So what does that mean? Well, look at this notation. If we read this, this is read f of g of x. F of g of x. And what that means is that you are plugging the g of x function, whatever's on the inside, you are plugging that into your f, okay? And because of the fact that it looks like this and it's read f of g of x, sometimes the notation looks like the following. You might see this where it's it looks like the word fog, but that's really f of g of x. So if it's an open circle, peeps, it is not multiplication, it means composition. So you just want to read it back to front. So g is getting plugged into f. So what I like to do is I always like to write, okay, well, what is the f? Well, the f is 2 times something plus 1. And notice I left a big gap for the something because we know that x is going to come out, and in its place the entire g of x is going in. So all of g of x is going right there. Now what do? Now you just distribute and combine like terms and call it a day. Okay, right there. 2x squared minus 4x minus 15. So that is your new function. So what about, now I've switched them. The g and the f have switched. So now f is going to be plugged into g. But notice it's not f of x. I've now switched it to a number, f of 2. Well, all that means, this is actually easier than the one above, because f of 2 is just a number that you could figure out first, then plug it into your g. So you kind of want to work inside to outside on these, or back to front, whichever is easier for you. But another way this could have been written was g of f of 2. So if you see that, it's synonymous with that. Now how do we do it? Okay, I'm going to do f of 2 first. So in the back, I'm going to figure out f of 2, and f of 2 is just 2 times 2 plus 1, okay, which is what number? That looks like a 5. Okay, great. So this actually just became g of 5. So once you figure out what that equals, you replace it, and now that's your new problem. So stick the 5 in, 5 squared minus 2 times 5 minus 8, and then whatever that is, 25 minus 10 minus 8, which is 7. All right, so that's how that is going to work. Okay, so the last one, f of g of f of negative 1. So it could have been written like this. And same thing, I'm going to work back to front. Who cares? Even if I had a million of these, well, that would be a long day. But no matter how many of these there are, you are still going to start with the back and just kind of work your way up to the front. So this is my first job, f of negative 1. Well, f of negative 1 is, what is that, negative 2 plus 1. That is negative 1, right? So basically, this is now gone, and it is a -1. So it shortens the problem like so. It gets rid of all that, and now there's a -1 back there. So what does that mean? Now I need to plug a -1 into G. So a -1 into G would be -1 squared minus 2 times -1 minus 8. So that would be 1 plus 2 minus 8, -5. So I'm getting a -5 right there. Double check me, but I feel pretty good about that. Plus, yeah. And so what that means is now this is a -5, and we're going to plug that into F. So you're just taking it step by step, back step, middle step, then the front step. So F of -5 is 2 times -5 plus 1. -10 plus 1 is -9. So that would be the final answer to the problem. Hopefully that made sense. You know, if not, feel free to rewind or talk amongst yourselves and help each other out. But there's going to be at least half the class that remembers this from Algebra 2. And in fact, some of you are probably angry and upset and wondering, why on earth are we doing this in pre-cal if you haven't shown us anything new, lady? Well, there is a little bit new for pre-cal. I'm pretty certain you never did this last year, and if you did, I guess I'm wrong and you had an overachieving teacher. But all that this is we're going to do the same thing we did above, but we're going to do this from a graph, okay? So I'm just going to make up like 3 examples. The first is just going to be like, alright, let me do an easy one, like f of 2, and then let me do like f plus g of x, and then let me do a composition. Yikes. Okay, so let's do like g of f of 3. Okay, so 3 very different kinds of problems by looking at a picture. Remember, these are just a bunch of points, guys, and so don't make it harder than it is. You know, f of 2 just means when x is 2, what is the y on the f graph? Okay, so when x is 2, and I go up to the f graph, which is this one, my y value is 1. So you really are just looking at the picture and finding a y value. Just be careful to look at the name of each function, because one's f and one is g. Okay. Now the second one, f plus g of x. Okay. The way that I do this is, notice how there's 4 good points marked on each of these graphs. Okay. So when I see that, I pretty much just do 4 math problems and figure out where they end up. Okay, I'm going to actually use a different color so that you can see it. Okay, so here's what I mean by that. Remember, this is just f of x plus g of x. So I'm going to first do 0. So what I'm going to first do is compute f of 0 plus g of 0 and then figure out where they end up. Okay, so what is f of 0? Well, when x is 0, the f is 2. And the g graph is -1. So what is 2 plus -1? Well, that's just a 1. So when I add this y and this y, I get this new y, and that's where I'm going to put a point. Okay? Now I'm going to do this again for when x is 1. Okay, so I'm not going to write it down anymore because honestly I'm bored of writing it down over here, but I'm going to do the same dang thing I did here, just with f of 1, g of 1. Okay, so f of 1 is 3 plus g of 1 is 0. So what's 3 plus 0? Well, that y value is 3. So it actually lands on top on that one. Okay, now I'm going to do the same thing for when x is 2. Okay, so when x is 2, this y value is 1, and this y value looks to be at about a half, I think. So what is 1 plus 1/2? Well, it's 1 1/2. And then I'm going to add these two together as well. So a y value of 2 plus a y value of 0 makes a y value of 2. And once I have these new vertices or points, whatever you want to call them, critical points, I'm going to play connect the dots. Okay, if these are straight lines, guys, then everything in between them is also going to be a straight line. Okay, so la 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 la. There we go. Okay, so that's it. So that red graph, okay, is the answer. There's not an algebra way for you to answer that unless you want to write a bunch of equations, but nobody wants to do that, okay? So that's going to be the answer for f plus g. Now the last one, g of f of 3, okay, we're just going to be careful and work backwards a little bit. I'll change colors again, okay? So once again, you start at the back or on the inside. So what's f of 3? Well, that just means what's the y value on the f graph when x is 3? Well, when x is 3, 1, 2, 3, where's f? Up here? Okay, it is 2. So all of that is just a 2. Now, what is g of 2? If I kind of bring that down, what is g of 2? Well, that would mean go to an x value of 2, then look on the g graph for what your y value is. This is g, so 1/2. So the final answer there would be 1/2. All right, so hopefully you've seen enough to where you can go and tackle some homework. I hope you guys have fun doing it. Just be careful with negatives. Be careful when you have a denominator, and be careful, you know, when you're on a graph. Just take your time and go slow, and you should be perfectly fine. All right, have fun.